What you are seeing in this video is an electrician working on live equipment while an arc flash event occurs. Our project involves making this a safer environment for this electrician. Our team, Arc Flash Incident Energy Reduction. We have designed an emergency bypass control circuit that will reduce the amount of arc flash incident energy at a given location on our power distribution. In the first step of our design process, we look at a typical scenario for a switchboard that has a main circuit breaker and a branch circuit breaker. Two important variables in arc flash are the magnitude of the fault and the time of the fault. So we must determine the trip settings of these two circuit breakers so we can control the arc flash at given locations. This is our trip setting simulator, and our first setup is uncoordinated circuit breakers, main breaker, branch breaker. As you can see in the video, both of our fuses will blow at the same time. Our breakers are not coordinated. We ran the same scenario in our power software, and as you can see, our trip curves for both circuit breakers overlap and trip at the same time. We now place a smaller fuse in the branch breaker section, and this will give us a coordinated result. As shown in the video, our branch breaker will trip ahead of the main. In our power software, we can actually move the main circuit breaker past the branch breaker to achieve coordination. Again, this is a typical tripping setup for a power distribution. Our emergency bypass control circuit design will automatically move that main circuit breaker time trip setting to the fastest possible while workers are present. This is our emergency bypass control circuit simulator. We have a relay acting as our electronic trip controller and a blade switch acting as the switchgear door pressure switch. This would be a normal condition. The door on the switchgear is closed. This is our simulation. We are using overamperage to simulate an arc flash event. Again, this is a normal condition. The circuit breaker, the main, is holding on. It's a longer trip setting. Normal conditions. We now go into the emergency bypass mode where a worker is present. They have opened the door on the switchgear, the pressure switch is released, and the main breaker trip setting is set to the quickest possible trip setting allowed. In bypass mode, when we go into overamperage, our trip is very quick and our arc flash is reduced at the main switchboard. Looking at our final design drawing, we have our power riser diagram at 6 o'clock. 9 o'clock we have our circuit breaker. 12 o'clock we have our MicroLogic trip unit. And at 3 o'clock we have our emergency bypass control circuit. The final challenge of our design was how to control our MicroLogic trip unit from our pressure switch. We have a 120 volt circuit controlled by our pressure switch at the switchboard door, inputting into a restraint interface module, and the output is a logic circuit into our circuit breaker MicroLogic unit. When the switchboard door is closed, our circuit breaker is in normal trip mode. When the switchboard door is opened by an electrician servicing the equipment, our breaker goes into emergency mode and will trip as quickly as possible if there is a fault. In conclusion, when our circuit breaker is in emergency mode, the tripping time is at its quickest. Therefore, our arc flash incident energy will be reduced at that location. Our final step was to print the labels generated by our arc flash software. As you can see, in normal mode, we have an incident energy of 2.7 calories per centimeter squared. In emergency mode, that number was reduced to 0.89 calories per centimeter squared. Thank you.